Good morning. Thank you for getting us going, Maddie. Really excited to kick off the showcase by sharing some updates on our project, where we're exploring ideas and questions around county collaborations for watercraft inspection planning. And so, as you know, I'll be presenting today with my collaborator, Selina from New Jersey Institute of Technology. But before we get into the updates, I want to do or provide you all with a refresher on our previous work that was led by my collaborator, Robert Haight at the USDA Forest Service and myself, which really sets the stage for the questions that Selina is answering through her work. So our previous work was largely inspired by the structure of AIS prevention and management in Minnesota and the unique challenges that we face here. And so, as you know, AIS prevention and management in Minnesota is quite unique, as it largely takes place at the state and the local level. And so at the state level, the Minnesota Department of Natural Resources Invasive Species Program works to prevent introductions of new invasive species, and they also limit the spread of invasive species that are already here. And then at the local level, counties work with other local government units to limit the spread within each county. And they do that primarily through $10 million that are allocated to the counties based on the number of watercraft trailer launches and parking spaces. And so a common prevention activity that counties use is watercraft inspections. And so within those, boats are inspected and decontaminated as they enter and exit lakes. And the inspections also serve as a tool to educate boaters on AIS prevention. But there are a lot of challenges in developing and implementing effective watercraft inspection programs, especially with limited resources. And so one of those is the vast number of lakes that exist here in Minnesota. We say with a land of 10,000 lakes, but in reality, it's closer to 12,000 lakes. Another factor is the large number of recreational boats that move across the landscape. In fact, in Minnesota, we had an estimated 880,000 registered watercraft in 2019, and recent reports suggest that there was a substantial increase in that estimate during the pandemic. And then, of course, there's differing risks and resources amongst counties that then also contribute to these challenges. And so to address these challenges and also gain an understanding of how different approaches might perform in order to overcome them, we aim to identify the most efficient placement of watercraft inspectors, and we did this at statewide and county levels. And we then quantified the inefficiency that might arise when planning occurs at these two levels, and we explored that through some bi-level planning. Further, we identified counties that could collaborate to increase the efficiency of county level planning, and then we made updates to the online dashboard AIS Explorer to help promote collaboration. So to accomplish these objectives, we developed a set of integer programming models that compared statewide and countywide scenarios. We considered starry stonewort, zebra mussels, Eurasian water milfoil as species of interest. And then we also compared a statewide, countywide, and collaboration scenario, and we added spiny water flea to the previous list of species of interest. For both integer programming models, we used the boater network that was generated from the Minnesota Watercraft Inspection Survey data that was collected between 2014 and 2017. And that estimated the annual movement of boats between lakes in Minnesota, which included 9,182 lakes. The network was based on outputs of a machine learning algorithm that was informed by over 1,600,000 survey responses, and was able to account for uninspected lakes. So given that the watercraft inspection program doesn't have inspectors at every lake, and then was also adjusted to account for bias and unequal effort, and that inspectors are placed at different lakes for different amounts of time. And so the models were informed also by the Minnesota DNR infested waters list, which was used to identify risky boat movements, which is a term that we developed that we'll use further in explaining our results, that we define as boats that move from infested to uninfested lakes. So in the statewide model, I'm showing here that a state planner selects lakes for inspection stations statewide to maximize the number of risky boats inspected with a given budget. And that's different than the bi-level model, which has two steps, where in step one, each county planner develops a set of optimal plans to optimize the inspection of risky boats within a county. And then in step two, the state planner comes and selects one plan from each county to maximize the risky boats inspected statewide. And so here I'm showing the results of the statewide and bi-level models with the number of lakes selected for inspection on the x-axis and the number of risky boats inspected on the y-axis. And then we found that, like the statewide model, the number of risky boats inspected in the bi-level model increases with diminishing returns, but there were less risky boats inspected than the statewide model. So we observed that almost all risky boats were inspected by selecting over 700 lakes, and that 600,000 risky boats were inspected in the bi-level scenario when 400 lakes were selected. And that's about 17% less than what we observed in the statewide model. And these findings are important because our statewide modeling approach can serve as a baseline to evaluate the efficiency of actual or proposed inspection station locations. And it was also important that we found that the bi-level approach to resource allocation is not as efficient as an optimal statewide coordination, and that inefficiency that we observed was not trivial. So then for objective 3, we wanted to know how counties could collaborate to increase the efficiency of their watercraft inspection programs. And to do this, we identified counties that send relatively high numbers of risky boats to each other, and then we rank those by the sending county. So we selected the top 3 and created a network by connecting counties within each other's list. And then we modeled the impact of the collaborations on efficiency by comparing them to a statewide and county level model at varying budget levels. And so this figure is showing the risky boat movements that shape those potential collaborations. So for each county listed on the outside of the circle, see, oh yeah, you can see my pointer here. The outermost ring determines the color that represents the number of risky boats coming from that county. And then the lines that span across the circle represent the risky boats that move to another county. So for example, this big purple line that moves across the circle shows boats moving from Crow Wing County into Cass County. And then the black line shows the boats moving from Cass County down into Crow Wing County. And so from this, we saw 2 collaborations form. In the upper right-hand side of the figure, we see Ramsey, Anoka, and Washington County, and those risky boat movements that are moving between those counties. And then the remaining portion of the circle is showing that Crow Wing, Carver, Wright, Hennepin, Cass, and Stearns. And those networks are shown here also on the right. So we then evaluated 3 scenarios, right? We looked at the statewide, the countywide, and the collaboration scenarios, considering these collaborations within the model. And here's what we found. So again, on the x-axis here in this figure, we're showing the number of inspection locations, and on the y-axis, that number of risky boats inspected. In the orange are the results from the statewide scenario, and in purple, the collaboration scenario, and then in blue, we have the countywide scenario. And here we can see that the statewide scenario outperforms the collaboration scenario and the countywide scenario, so both for all budget levels. In the statewide model, just as we saw in objectives 1 and 2, the number of risky boats observed peaked around 400 inspection locations, and significant gains were not observed by placing many more inspectors. The collaboration scenario resulted in more risky boat inspections than the county-based scenario. It outperformed it by approximately 65,000 risky boats at a budget of 400, and that represents about 8% of the possible risky boats. And so these results indicate that collaborations between counties may be a way to build on all the benefits of local level initiatives while also increasing efficiency. And Selina's work will drill down on this point a bit further. But to share the work and to help promote collaboration, we incorporated these ideas in this work into the online dashboard AS Explorer. And so that's available here at, I'm showing the URL, www.asexplorer.umn.edu. And in the prioritization for watercraft inspections tab, there's now 2 new options. The first is a collaboration sub-tab that comes up if you select a county that's included in the collaboration networks that were generated from the risky boat analysis I described. The results are slightly different because we're using updated infestation statuses. So keep that in mind if you see something different. And then there's also a paired planning sub-tab, and I'll describe that in a few slides. The collaboration sub-tab will then take you to the county collaboration. We'll show you the county collaboration on the left side and the structure of how the risky boats are moving between the lakes and the counties. here as you see on the right side. And both figures are available as a map. So this is the network form, but if you toggle over to the right, you can then see them in a map form. So you can go back and forth and kind of compare, maybe taking up the information in one form versus another works better. And then as you scroll down the page, there'll be a group planning output that ranks the location for watercraft inspection stations. And this output is just like the current watercraft inspection tab, the output that you would get there, but it now includes all the lakes and the collaboration. And then further down the page, there will be an option for paired planning where counties can select lakes for inspection stations and see how that impacts the ranking of lakes in the other counties in the collaboration. And it's important to note here that the paired planning analysis is also available to all counties through the watercraft inspection tab, even if they're not part of a collaboration. So when you go back to the watercraft inspection tab and see the 2 new sub tabs, if you click on the paired planning, that option would be available to any 2. You can select any 2 counties in the state. So I know that was a very quick overview of the information that we've presented. So I'll urge you to reach out or visit the MACERC YouTube page to watch our previous showcase presentations where we go into more detail on those. And then I also want to say that we're planning some workshops for late fall and winter, and we are going to share updates to AS Explore in more detail. And there's some other updates that we'll get into in presentations during the showcase. If you're new to the tool and you're interested in hearing about it, or if you're experienced and you're just curious about the updates, please reach out to Maddie, who's our new research outreach specialist. And I've included her email here. And then with that, I will pass it off to Selina.
Thank you, Amy. Hi, everyone. Thank you for your time and being here. Today, I want to show you a game theoretic model to enhance the resource sharing among county planners. This work is jointly done with Ezra and Robert, both are professors from Virginia Tech, and their PhD student Huang Wu Li, in addition to Bob Haidt from Forest Service and Amy from University of Minnesota. As mentioned earlier by Amy, the county planners who receive the AAS prevention aid develop their own water inspection plans. But due to there are no formal collaborations among the counties, it is then challenging for the county planners to reduce inter-county infestations. So our goal is to address that challenge and also make the most efficient use of the resources. To do so, we want to develop a game theoretic model where the county planners can be motivated to collaborate during the planning process of their water inspection programs. Ultimately, we want all county planners in Minnesota to work together if they wish to do so and create solutions that benefit all. We also wanted to assess the effectiveness of the game model by comparing key metrics with the countywide model and statewide model that were developed by Bob and Amy previously. So let me set up the game between the 2 counties. Each county planner in this case will make his or her own decision by selecting a set of lakes to inspect while considering the other county planners' inspection decisions. The goal here is to maximize the number of risky boats inspected in each county. We use the same definition with risky boats as boats that travel from infested lakes to uninfested lakes. So here is a visual representation of the input to the game model. County A has a set of lakes named A1 all the way to AI, and County B has another set of lakes named B1 to BJ. For all the other counties that do not participate in the game, they're aggregated together and referred as County O. For a county planner A to make the best inspection decisions, he or she needs to consider the risky boats moving within the county, which are represented by the blue arrows, as well as the risky boats coming from County B, which are represented by the green arrows, and the risky boats moving from County O to County A, which are represented by the pink arrows. In the next page, we show you the results of or the output of the game model. So in this example, each county is allowed to select 2 inspection stations, and therefore County A will select A1 and AI, and County B will select B2 and BJ. In the next page, I want to show you some of the key assumptions that we make in order for the game to work. First of all, the 2 counties who participate in the game must share the same information, and that includes the boulder movement network, the list of lakes that are considered to be infested, and also how many inspection stations each county is planning to set up. For the other counties that are not participating in the game, we assume that none of the risky boats coming from those counties have been inspected. Also, for County A, it only considers risky boats traveling within the county and coming from outside the county. It does not consider the risky boats traveling from inside County A to the other counties. This is just a set of notation that we use in order to write out the integer programming problems to be solved in the next slide. So in the left, you will see County A's optimization problem, which is to maximize the number of risky boats inspected in County A while considering the inspection decisions of County B. On the right, you will see a similar optimization problem for County B, which is to maximize the number of risky boats inspected by County B while considering County A's decision. So the programs are solved jointly and in an iterative manner. In each iteration, the county managers are allowed to select to change the set of lakes that they're inspecting, so long as it will improve the county's overall performance. When neither county can make any further improvement unilaterally, a pure Nash equilibrium is reached. At that point, both counties are committed to implement the strategies they have identified. So I want to show you a very simple example where we have a hypothetical state that only has 2 counties. The risky boat movement are generated randomly. We only consider a zebra mussel. In this case, County A has 3 infested lakes, A1, A2, and A3, and County B has only 1 infested lake, and that is B2. The graph is simplified. We're only representing the risky boats here. And we also assume that each county can only set up 1 inspection station. Before we go to the solution of the game model, I want to talk about what the inspection plan would look like if it was implemented by the county-wide model, which was developed by Bob and Amy previously. Just to remind you, in this model, each county will make its own decisions to maximize the number of risky boats inspected in the county. However, they will not be collaborating with any other counties. So the best inspection plan selected would be County A choose to inspect A4, the only uninfested lake in the county. And as a result, County A would have 32 risky boats inspected. On the other hand, County B will select to inspect Lake B2, which sends out the most risky boats within the county. And as a result, County B will have 52 risky boats inspected. On the state level, the aggregated number of risky boats inspected is 84. Now let's look at the solution provided by the game model. So instead of County A selecting A4, here County A will select to inspect A1. And County B still selects to inspect Lake B2. As a result, County A does not have any improvement in terms of performance, but County B does end up with 62 risky boats inspected, which is 10 more than what they would have previously. On the state level, there are 94 risky boats inspected altogether. Again, that's that's an increase of 10 risky boats being inspected on the state level. I also want to compare the inspection plan generated by the game model versus the statewide model. So in the statewide model, the central planner pulls the funds of both counties and make decisions to maximize the total risky boats inspected on the county on the state level. As a result, the central planner has the option to reallocate resources, meaning if it's beneficial, the central planner may choose to allocate both inspections in County A, or allocate both inspection stations in County B, or one each. It turns out that the optimal solution to implement this model is for the central planner to select A2 and B2 respectively. However, County A only has 15 risky boats inspected, even though County B increases in its performance and having 90 risky boats inspected. And on the state level, again, there's an increase in the total number of risky boats inspected. So to compare these three models, we can state that collaboration in the form of information sharing is beneficial to at least one county. At the same time, it does not make any counties worse off. However, it's important to note that this result only holds when a single type of invasive species is considered. Comparatively, the state planning model, even though it can optimize the overall number of risky boats inspected on the state level, however, it may benefit one county at the expense of another. Next, I want to talk about implementing this game among all counties in Minnesota. So in this case, we assume that all county planners who have received the state aid in 84 counties will be working together. And therefore, every county planner is aware of what the other county planners are doing, and they can change the plan accordingly if it benefits the said county. We use the Boulder Network data generated from the 2014 to 2017 survey and the list of infestation lakes in 2019. We only considered the zebra mussel in the model, and we assume that the fund used for the inspection program in each county is proportional to the state allocated fund that it receives. So if 50% of state allocated fund is used, then this is equivalent to 420 inspection stations being set up statewide. We were actually able to find the pure Nash equilibrium solution among all of the counties. And in the next slide, in the next two slides, is the inspection plan. So here there are 5 separate models being shown in each, there are 5 separate tables being shown in each table. The first column highlights the county that we're referring to, and the second column highlights the names of the lakes that will be selected for inspection. So for example, County Aiken will inspect 11 lakes, and County Anoka will inspect 6 lakes. And because there are 420 lakes selected to be inspected, it does not fit into one page, and the second page shows the rest of the county and the lakes being selected. I want to talk about the value of collaboration by comparing the number of risky boats inspected on the county implemented using the countywide model versus using the game model. So the only difference between the countywide model and the game model is that countywide model does not consider collaboration among counties, while collaboration consider counties among all counties in Minnesota. So for example, Polk County inspects about 4,000 risky boats without collaboration, but that number can be brought up to close to 5,000 if collaboration is being considered. So this is equivalent to an improvement of 24%. All the counties highlighted in green receive an improvement above 20%, and all the counties highlighted in blue receive an improvement above 15%, and all the counties highlighted in yellow, which continues in the next page, receive an improvement of over 10%. The counties highlighted in gray only receives an improvement of over 5%, and the counties highlighted in orange receives an improvement below 5%. The ones that are not highlighted do not receive any improvements. However, it's important to note that no counties are being hurt by using this game model compared to the county-wide model where no collaboration is considered. On the state level, the improvement is reached at 12%. So next, I also want to talk about the limitation of the collaboration or the game model. So here we're comparing the number of risky boats inspected by the game from the game model versus the number of risky boats that can be inspected by the statewide model, broken down by each county. So the counties that are highlighted in green, the performance is 100%, meaning that we inspect exactly the same number of risky boats in the game model when compared to the statewide model. The ones highlighted in blue, the counties that are highlighted in blue, the performance is at or above 90%. So this means that out of all the potential risky boats that we could have inspected, we can inspect 90 to 99% of them using the game model. The ones highlighted in yellow have a performance about 80% and above, and that continues on to the next page. The ones that are highlighted in gray have a performance between 70 to 79%, and the ones highlighted in orange falls below 70%. Overall, at the state level, the performance is about 77%. So I just want to do a quick summary of our results. Information sharing is shown to be beneficial to most counties, and none of the participating counties will be worse off. We can actually prove mathematically that the performance of the game model is always higher than that of the county-wide model. So that demonstrates the value of collaboration. And this result is irrespective of the boulder network, and it only holds when a single type of invasive species is considered. However, we cannot provide a lower bound on the performance of the game model when compared to the statewide model. Again, because in the game model, we take the current funding allocation as it is and do not change we do not change the allocation of funds. We cannot perform as well as the state level model. And this is the limitation of the work. Yeah, so just to give you a quick summary of our planned future work, we are currently investigating the next level of collaboration, which is the potential benefit of a partial fund transfer from one county to another. We want to find the characteristics of county infestations that can benefit from such collaboration and create win-win situations for both counties that are collaborating. We want to also develop a game model to foster collaborations among county planners and the DNR to achieve a better outcome. We also want to update the boulder movement networks and integrate some of the model outputs into the AIS Explorer.
Great. I just want to jump in and acknowledge our collaborators who were instrumental in pushing this work forward. So I want to thank again Robert Haight, who helped with all of the work that I presented previously, the folks from Epi Interactive who really helped build out the AIS Explorer with us, Alex Badges, who's a quantitative ecologist for MACERC, and also Nick Phelps for leading a lot of the work related to the boulder movement network and the modeling that has also been done with AIS Explorer. I'd also like to thank the stakeholders who've engaged in this process along the way and folks who've weighed in on work that have led up to the models and the outputs that we've created. And with that, I'll invite you all to submit questions.
Can you elaborate how these results can be translated into practice?
Yeah, so that's a great question. It kind of touches on the point that there's a lot of theoretical work done here within developing these models and some of the outputs that we've gotten. But I think a lot of this helps us formulate our thinking around how this would be implemented in practice, and seeing how we build the tools within AS Explorer is a great example of that, right? So taking those collaboration networks and importing them into Explorer, AS Explorer, and then opening that up to see the rankings and the interactions between the counties, I think can be really powerful in, even if we're not developing watercraft inspection planning explicitly off that, at least conversations around how collaborations could unfold, and hoping that it kicks off some conversations between county managers where maybe that wasn't done before. And again, I'll urge folks, if they're interested, to participate in the workshops, because I think what's valuable for us is to hear the needs of the county managers, what they're thinking in terms of collaborations, what are the barriers, and what other questions they would like for us to touch on conceptually. I think that's really important to help bring us even further into that kind of implementation into the real world. And we love that co-designing aspect where we work back and forth with, here's what our models build, and I'll show you what that kind of initially looks like. Let me know further what it is that you need. So that's kind of what I envision.
Okay, great. We've got a couple questions. So I can't help but wanting to consider the counties with a larger volume of inspections, in addition to comparing the game versus a statewide analysis. So what are your thoughts behind this? So again, looking at the counties with those larger volumes of inspection and comparing the game versus more of a statewide analysis.
I think the results vary for the counties with larger volumes. In the statewide model, there will be a tendency to allocate more resources to those larger counties with larger volumes of lakes, or lakes that sends out many risky boats. And therefore, the game model would not be able to achieve that kind of efficiency unless the funding is reallocated.
All right. Do you have thoughts or any preliminary results on how collaboration performance would be impacted by considering other AIS, whether it be multiple or different alternatives?
So I think the results is similar. If we were just changing zebra mussel to a different type of AIS, we can, as stated earlier, mathematically prove that the game model will always outperform the county-wide model. So again, demonstrating the value of collaboration. However, when we're accounting for multiple type of invasive species, we may not be able to reach a pure Nash equilibrium. So this will then require us to implement a mixed Nash equilibrium, which would entails, a probability of implementing one strategy and then using another probability to implement another strategy. So I think the outcome of that is harder to predict.
Thank you. All right. We have a few more questions rolling in. So what if the counties are not spending 50% of their budget on watercraft inspections? How does that impact the output of the game model?
So I think the lower the amount of fund that's spending in inspecting the risky boats, then fewer risky boats will be inspected. However, it is important to know that if we are to implement this collaboration in real life, then the county planners can get together and share how many inspection stations that are planning to set up, and this is all we need. We don't need every county planner to commit the same amount of resource in order for this collaboration to work.
So feeding off that answer, if the goal of the county may be protecting a high value lake, instead of just checking the highest number of risky boats, how is that factored into the research, or how could it be factored in?
Yeah, so this is a great question. In order to do so, we really need to assign different weights to the different lakes in order to reflect that in our model. Currently, we do not have that data, but if anybody has results or data related to that, please reach out to us and we can definitely include that or modify our model to include that aspect.
I just want to jump in here as well, because I see Josh's question and I really appreciate this one. I think this is an interesting point. And I just want to note that currently the way we've allowed the outputs to be shared through AS Explorer, where we have that paired planning, those folks who are, if you're selecting lakes for inspection, the ranking is the default output, but you can select different lakes within there, right? So you don't have to inspect all of the lakes based on their ranking. If you have a lake that you know stakeholders are really invested in having inspections at, or you know that ecologically it's an important lake, you can go ahead and put an inspector there and still see how that impacts the other county, and you guys can work together to develop planning that works. Just a nugget.
All right, Selina, we have a question for you. In future work, are you going to explore mixed, I'm going to botch this, Nash equilibrii solutions for problems with multiple AIS?
Yes, there's something we're looking into right now. But as mentioned earlier, implementing a mixed Nash equilibrium solution will be difficult.
Oh, I see one more that I missed. And this is just a kind of a comment statement. So with that, can we look at this as a statewide model that can be implemented, or is that not a feature yet?
Can we implement the game model as a statewide model to be implemented? Yes. So right now we are assuming that all county planners will participate and share the information on how many inspection stations they're planning to set up within each county. So we are looking at the problem on the state level, but individual county is always keeping their best interests in mind. So this is why we have separate integer program for each county, and we're solving them iteratively, and we're solving all the problems jointly, but in an iterative manner. So what's nice about the game model is that it keeps individuals' interests in mind, but also we're evaluating the aggregated performance on the state level, and we're comparing that to the statewide level. And I think earlier there was a question about whether the statewide model can be implemented. The answer is no, because this will require us to pull back all the $10 million with the central planner, and the central planner needs to reallocate the resource in order to achieve what the statewide model is trying to achieve there.
I think this might be the last question. So this is building back from Josh's point that Amy was also elaborating on. Many counties are receiving funding from lake associations to dedicate county inspectors at their lake. This may decrease the overall efficiency of intercepting risky watercraft. Can the model include such a scenario?
Yes, the model can definitely increase that such scenario. If the certain lakes have already been deemed to be inspected, that can be implemented as a decision. However, I'm not sure I agree with the statement that this may decrease the overall efficiency of intercepting risky watercraft, because the lake association have contributed funding to the overall funding. So we're simply increasing the number of inspection stations. And the more we're increasing the number of stations, the better we are. So the result may surprise us that this is an overall increase in the number of risky boats that we can intercept.
Yeah, absolutely. And thank you all for the interesting questions. Hearing your thoughts and the way you're thinking about these, this topic is really interesting for us as well.